Hey, what's going on, folks? It's Mike here, and welcome to our next lesson in the D programming language series. In this lesson, I'm going to talk about the basic data types that are available to you in the D programming language. And these are our foundational structures or built-in types that you'll use to build higher level abstractions for representing your data. So it's important to understand these and see what's available by default. Now, D, in my opinion, gets a lot of the defaults right here and even adds some cool properties to the basic data types so you know exactly how large each of these data types are. I think there's some lessons learned from some other programming languages, but with that said, let's go ahead and take a look here. Now, in order to get started here, I just want to talk a little bit about memory. And the way I think about memory is those little green sticks of RAM that you add in. These are called DRAM, or the dynamic random access memory here. Those little, 4, 8, maybe 16 or 32 gigabyte sticks that you access and have all these pins on them, have essentially a bunch of cells here where you store your data. And these data that you're storing is in memory. So it looks something like this. You can think about it as having, some address here from some range. Let's just go ahead and say from 0 to, some other memory address. And depending on how much memory you have a lot of different addresses here. So I'll just put ... and show that it's sort of growing up here. Or you can think of it in the opposite direction. But anyways, what I want to sort of convey with this, if this is new to you, this idea of understanding memory, is anytime I create some data, so let's say I have a character here, I just call it A, and I call A here, it's allocated somewhere in this memory here. So it might be placed here, for instance, where A goes. Now, let's say I create another data type here, int, and I'll call this B here, and I'll set it equal to -42. That'll also be placed in memory. But if 42, or rather the type here, that's on the left-hand side, int, can represent a wider range, we need more memory here. So in this particular case, I happen to know that I need 4 bytes, or 4 of these blocks, to represent -42 here. Okay, so I need to cross off 1, 2, 3, and even 4 of these cells here. So that's the idea, that we need to use this amount of storage to store some range of values. Now, depending on other data types that we use, for instance, like doubles, which can represent numbers with a floating point value, so I'll just put some number here, like 3.1415, 26, etc. We again need more precision. And that means we need more memory here. There are single float precision numbers, so I'll just do float here, which again, if I create some other value here, maybe 3.14f or something, we don't need as much memory. So we do have to think about how much or what range of actual data that we want to store. And that's what we use our basic data types for. So with that said, let's go ahead and explore some of the fundamental types that we use in the D programming language. Now, I've copy and pasted the different data types that are available to us. And I just want to kind of show you how to explore these so you can understand the properties of each of these data types here. So let's go ahead and start from the top here. And let's go ahead and pick out one of the 8-bit or 1-byte data structures here. So what I'm going to go ahead and do is just write out a line here. And let's just go ahead and say we have a char here and the size of that character. So let's go ahead and use RDMD to do some introspection here, and we can confirm that the size of this is 1 byte. So again, that's what I'm outputting here, which is the same as 8 bits of information here. Now we can use these for individual characters that we create here. So let's just go ahead and create a character A, and I'll place in 1 character here. And I can go ahead and just change char here to that actual variable if I want here. So that's a cool thing in the D programming language, that I can, again, see the properties of a specific variable. I can either put in the type explicitly if I want, or we can figure out at compile time that A is a char, so let's go ahead and just check what the size is. So that's a pretty cool thing in D. Another cool thing that we can do here when exploring our basic types here is seeing, well, what is the actual type here? Let's go ahead and confirm that A is in fact a character here, and we can again see our assumption that it is one of the 8-bit or 1-byte data structures here. So I'll go ahead and run this here. Oops, looks like I made a bit of a mistake here, forgetting my parentheses. And as we go through this series, I'll leave in these little syntax mistakes just so we can get used to reading the D errors, which are pretty good. So this told me to add a right parenthesis here. So let's go ahead and rerun that. And again, we can go ahead and see it's printing out that, well, the type is a character and the size is 1 byte. Now, what I think is pretty cool here about the deprogramming language is we're not limited to just this property here. So we actually have some other properties here that I want to use, such as the min and the max. Because remember when I was talking just a little bit about in our mini introduction here about memory, depending on the range of values that we want to represent, we have minimum and maximum values here. So let's go ahead and see for a character, sometimes pronounced char, what that is. So I'll go ahead and run this quickly, and doesn't look like it's printing anything out here. And what I'm going to have to do here, which is a little bit of a hack and something that we're going to talk about in one of the next lessons, which is about casting, is to actually write out some value here. Now, I happen to know that this value is going to be something like the value 0 in this case, or 255, which when printing out those characters isn't quite going to work. And we'll have to talk a little bit about strings later on in this series to understand that. So what I'm going to go ahead and do is just cast this to something that I know is a value here that we can take a look at here. And then if I go ahead and run this, we'll go ahead and see that, well, the minimum value allowed here is 0, and the maximum value allowed here is 255. So if we actually look and see what those printed characters are, 0 and 255, I think 0 is null and 255 is some other character. That's why it wasn't printing. But that's the idea with this type here. Now let's go ahead and play around with some other types here. And what I'm going to go ahead and do is just change this to a boolean here. And I'll leave it as a here, but I do need to specify that this value is something that is either true or false. So let's go ahead and rerun this and explore some of our types here. And we'll go ahead and see bool in this case. Well, it looks like we have identified the type correctly. That's what we've got here. The size, 1 byte here. It looks like it's still using 1 byte for the 8 bits. I'd have to confirm that, but that looks like the case here. But the range that is enforcing by the type system is, again, a 0 or 1 value or true or false here. Okay, so that is the idea. And let's go ahead and back up here and just see something with a decompiler. Let's see if we don't initialize this value here and we try to run it. Well, it'll still run here. But another property that we have here is if I go ahead and rerun this here, is we can go ahead and try to see what is the initial value here. So let's go ahead and rerun this, and we can see that it is in fact 0. So D does give us some defaults for our particular values that we create, which is nice. And again, it's a source of programming error. Okay, so with that said, let's go ahead and run this with a few other types here, like a short. And let's go ahead and rerun this. So we can go ahead and see short. We see this time it takes 2 bytes, and we can see the range here. Now short, again, is a sign type, meaning we can have negative values to positive values. So again, this range of negative 32,768 to a positive 32,767. So again, that's the amount of information that we can store in 2 bytes or 16 bits as we move along here. Now you'll also notice that most of the types that we have also have a U in front of them. So what U means is that it's going to be unsigned. So let's go ahead and rerun this. This time, again, just changing this to U short. And now we can see that, again, that minimum range is 0 to 65535. And again, it's important when using basic data types, and I'll probably capture this in another lesson, that we try to compare things reasonably. So again, D has these sort of unsigned types that we should use when we expect our data can, for instance, never be less than 0. So if you're representing someone's age as a data structure, for instance, you should probably use an unsigned type for this reason. Now, D also gets a couple other things right, or provides as defaults here, things like W character, or usually wide character. So if I go ahead and run this here, you'll go ahead and see it's the same 16 bits here, but you'll say, well, why do we need this to represent some characters, for instance? It seems similar to the actual character. Well, the reality is there's different character sets, and there's many different types of representations of characters beyond just the sort of English alphabet if you're trying to represent that. So we have those as built-in types, which again is really nice to have these defaults. Now, let me go ahead and just run a few more examples here. Let's go ahead and actually put in our int here and run this, so you can again see that it's 4 bytes here. And you can see the range is getting bigger. I'm eventually going to have to cast this to something larger. For instance, when I want a long type here, let's see if this breaks here. yeah, it's not going to give me the right values here. So I have my type here, which is long, 8 bytes. And if I try to look at the min and the max, it's essentially just giving me garbage here. So I need to actually see what the range is here by casting it to a bigger type here so that I can store all the bits here. And again, you can see the maximum and the minimum values here for a long type. So again, later we'll have to get into the casting rules when we use different data types here, but this is just the idea here. All right, now lastly, let's go ahead and take a look at float here. Now we are going to actually see here that this one's kind of interesting, that there is no min property for our actual float here. We actually have some different properties for it. So at this point, let me go ahead and bring in the properties page just so you can see where to explore this. So if you go to the deprogramming page here, and let's just go ahead and do Control F for properties. You can see this is on the left side here. And you can see for our integral types, these are the properties. We have min, max, and the initialized value here. So integral properties being integer, shorts, these types of things here. Char, bool, things that don't have decimal points. Now for our floating point, we have some other properties that we can actually check for. And this is super neat because we have things like epsilon, which might be useful, again, for programmers who have programmed a little bit. You might know of cases where comparing floating point numbers can be difficult. For new programmers, don't worry, we'll talk about this later. Let's go ahead and just see the max value, though, for this floating point value here. So let's just go ahead and hide our min. Again, looking at the D error message here, it's at line 8 is where we had that problem here. So if we run this, we should still be able to see the max value. Now it is a little bit messed up here because we're casting to a long. So let's go ahead and just treat this, say, as a double here for these values. And if I go ahead and take a look at this, well, this is our maximum value here. It looks like our initial value is not a number here, which is something that we can have here. Or rather that we can compare against here. So it looks like this is not initialized to anything meaningful. And again, just to double check this, let me just cast these to a float here. Let's see if that makes any difference. Nope, looks like not a number is, in fact, the initialized value. So again, you're not going to memorize all these things. That's where these web pages are really useful for you, so you can go ahead and see what's initialized. And again, the documentation shows you, again, not a number, so looks like everything is working just fine. So again, I just think it's very useful to know how to query some of these properties, that these things are built in. You don't have to make magic constant numbers or anything like that in the deprogramming language. Again, we have these properties here that can be set for our symbols and can also be just queried here. So I think that's super useful. Again, you can see for all types, the types of things that you can have set up here. So once we start creating our own types, that can be useful. But now you know about the fundamentals here. Now, again, what is the important thing or what's useful about D, and I'll go ahead and close off this lesson, is that these types are known their actual sizes. So this isn't necessarily guaranteed by other programming languages that an integer is in fact going to be 4 bytes of memory. So that's really nice. Other programming languages will have sort of fixed with data types that you can use, but in D, an int is just 4 integers, which again is a really nice guarantee to have as you are programming. So with that said, I'm going to go ahead and end this lesson here. I hope you enjoyed it. I hope you learned a little bit more about D and just get to see some more great things about this programming language. So with that said, we'll keep moving on, and I'll look forward to seeing you in the next lesson.